All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? Warm-up number 43 is on the screen. Very similar to the one we did yesterday. And number 1 reads, complete the square and factor. And they give us the binomial x squared plus 8x. For number 2, it says simplify. Part A reads square root of negative 16. Part B reads 2 over square root of 5. And part C reads square root of 55. Number 3, factor by grouping. They give us a trinomial, x squared plus 8x plus 12. Number 4 reads find the inverse function f inverse of x for the given function f of x. And the original function that they give us is f of x equals 5x minus 2. So let's get that done. Hopefully by now you should be able to do all 4 of them. And I'll give you some time. Ready and go. Alright, let's see where we're at. Number 1. Complete the square and factor. So let me go over this one more time. So they give us x squared plus 8x. We need to complete the square. That means we need to make it a trinomial. So we need to add one more term. One more term. What would be that term? That means we need to take the coefficient of x divided by 2 and square it. So if I simplify that, we end up with x squared plus 8x, and 8 divided by 2 is 4. 4 squared is 16. This is already completed. This is completing the square. Can I factor? Yes. 16, 8. Factors of 16 that add up to 8, 4 and 4. Therefore, see what I did there? Bam! X plus 4, or in other words, x plus 4 squared. Hands if you got that by yourself. Okay, some of you. Okay. 2a, you should be able to get 2a by yourself, yes? So, what'd you get for 2a? Carlos. Alright. How about, Christian, what'd you get? 4. Okay, close. Brandon? 4i. Hands, have you got that? Yeah, that is correct. Yes. For part B, in order to get rid of the radical or the square root on the denominator, we need to multiply square root of 5 top and bottom. So we end up with 2 square root of 5 over, what is 5 times 5? That's square root of 25. So 2 square root of 5 on the numerator. What is square root of 25? 5. And that's how we get rid of that square root. Part C. We can't take the square root of 55 because we're going to get a decimal. But we can take the square root of a number right before 55. What number below 55 can we take the square root of? 49, yes. How about above 55? 64. So that means square root of 49 is 7. Square root of 64 is 8. So that means this one's going to be between 7 and 8, yes? So this is going to be approximately 7 point something. How do we find that something? Well, we subtract the middle from the small. That gives us 6 divided by the large from the small. That's 15. And we do the division. 6 divided by 15 does not fit. Add a 0. That's 4 times 0. So that is 7.4 approximately. And number 3, after you factor this, 12, 8, that's 2 times 6, yes? So you write x squared plus 2x plus 6x plus 12 You group, you end up with x plus 2 and x plus 6. Yes? Alright? And last but not least, find the inverse. I'm going to go over this one more time for those of you that still don't see it. Rewrite f of x as y. Solve for x. That means I add 2. Y plus 2 equals to 5x. Then divide by 5, y plus 2 over 5 equals x. Is that the inverse? No, I just solved for x. What makes it the inverse, Mr. Q? Well, when we exchange the variables, or we swap the variables, so this is written as x plus 2 over 5 equals y. This is the inverse. We just need to write it in function notation. Can I use f of x for y? No, because this is for the original one. Since this is the inverse, I'm going to write, instead of y, f inverse of x. And what goes on the other side? Well, what do we get there? X plus 2 over 5. There you go. Alright, copy the agenda for today. Warm-up number 43, transformation of functions. Home play, only 3 transformations for today. Alright. Your Nearpod code, PMTDI. Alright. So last night's home play, it was only 4 transformations. Go ahead and go to Canvas, turn that in right now, please. I'll give you some time. From there, get a Cornell note ready, and by now the person from your row should have taken you graph paper, yes? Someone? Alright. And those of you joining us online, you are absent during your home play, and that's the home play for tonight. Alright, so once again, your home play for tonight is only going to be 3 transformations, but if you notice, we're adding more stuff to our transformations as we go along, so make sure you keep up with your work, please, pretty please. So let's move on. I can transform functions, or a function, using different parameters. We're still transforming. We're still in the introduction part, because we're about to get into the funner part of the course. And we know what functions are. We don't need a fair model. We know what parameters are. Is that correct? So we've been working already with some parameters. Tell your neighbor which parameters we've been working with and what do they do. Talk it over to your neighbor, please. What are the parameters we've been working with and what do they do? Be nice. Alright. So it looks like here H and K, is that correct? Where K goes up and down and H goes side to side. Yes, those are the parameters we've been working with, yes. We've been transforming using that. We know what functions are. We don't need a Fourier model. And here it goes again. Here's our general rule. My parameter K goes up and down. Up if it's positive, down if it's negative. H, side to side. Positive, it goes to the right. Negative goes to the left. Okay? Alright, so quick recap. Yesterday we finished up with this one. Well, we did some more stuff, but we did this one yesterday. So before we move on, look up to the screen. Here's my original cubic function. So, according to transformation D over here, as in David, tell your neighbor where we're going to move this original one. Alright, let's see. How about, where are we moving that one to? Raymond. Close. We're moving this one to the left. That is correct. Alright. And why to the left? Because the general rule, let's go back to the general rule. What does the general rule have inside of the parentheses? A minus, yes? So what number would I substitute in here to make this a positive? A negative number, is that correct? That takes us to the left. So this one became a positive 7, which means we substituted a negative 7. Alright, tell your neighbor the rest of the transformation, see if they get it right. The green one, the red one, and the blue one. Talk it over to your neighbor, please. All right, let's see if we got it right. Here goes what we did yesterday. The green one goes up 2 steps. The red one goes down 3 steps. The blue one goes 6 to the right. And the black one, we said 7 to the left. Hands if you got that. Yeah, we're getting there. Okay. So today we're going to move on. That was fun. All right, here we go. So, on your big graph paper, copy this down, please. Example, super duper cute. We have f of x equals x squared using the domain -3, -2, -1, 0, 1, 2, and 3. We're going to graph that, so that means we need a table. So on the left side of the big graph, I want you to draw this table. X with a domain -3 all the way to 3. Leave f of x open because we're going to do that together. Underneath that one, draw this table in green. I'm going to put it in me if it's to the right of mine because I want it on the screen, but for you it's going to be below the other. And then this table in red, below the other. The original has f of x, the green one has 3f of x, and the red one has 1/3 f of x. Copy that, I'll give you some time. Alright, so let's start filling in the first table as you're copying that one down. So now guys, remember the first 3 parent functions that we've been working with, the linear, quadratic, and cubic. This is the quadratic. And this is how it goes a little bit faster. I'm just going to show you the first work, just so that you know what we're doing. We're substituting these values in here. So what is -3 squared? That is +9. And then for the rest, we don't need to show the work for right now. Let's just fill in the table. What is -2 squared? 4. -1 squared? 1. 0 squared? 0. 1 squared? 1. 2 squared? 4. And 3 squared? 9. All right, let's plot that. -3, 9. -2, 4. -1, 1. 0, 0. 1, 1, 2, 4, and 3, 9. Let's label that f of x. That's our original quadratic function. It's a parabola. All right. All right, so for today, we have a couple new transformations. So, writing utensils down, let me show you the first one. Ready? Here we go. All right. Ready? Look up to the screen. If you notice, here we have f of x, but what do we have in front of it? A 3. That means it's multiplying f of x by what? 3. By 3. So where can we find f of x? Over here. This column right here. Which means when x is negative 3, f of x is 9, so what is 9 times 3? 27. Fill that in, please. Which means the next f of x value is what? 4 times 3 is 12. The next f of x is 1 times 3 is 3. 0 times 3 is 0. 1 times 3 is 3. And then it repeats, yes? All right, let's graph that. All right. So can we graph 27? No. So we're going to start at negative 212. Negative 212. Oh, that's 13. Let me go down one. There it is. Oh, no, it was. Sorry. Negative 212. Negative 13. 0, 0, 1, 3, 2, 12. All right. So now, something happened to the original to get that one. You're like, yeah, we multiply, Mr. Q. Yeah, I get it. However, this is what I want you to think about. Look up to the screen. I don't know if you guys seen those pegboards with nails that sometimes they put like string or they put rubber bands to make like figures. Have you guys seen that? They put a board like that, they put nails and they get rubber bands. So imagine I got a rubber band and I made the original function. There it is. And then in walks in your little person in your life. You guys have like a little cousin, nephew, or brother, sister. You're there doing your Algebra 2 home play, eating your hot Cheetos. They come in, they want to take your Cheetos, and you have to give them some or else you get in trouble, yes? And they ask you, well, what are you doing? And then you're going to explain, well, this is the original one, and now I got this one. What would be one word you would tell them happened from here to here? Talk it over to your neighbor. What would be one word you would tell them that happened from the original to the new one? To get that new one. All right. And mind you, we still haven't graphed the 27 one because we do need it, but it's way up there. Okay? So what is the one word you told your little person you did to this rubber band to get this new one? What was that one word? Miguel. It got smaller? Not quite. What do you think, Raymond? The what? Yeah, it's a transformation, yes. Okay. What do you think, Bree? Okay. So, here's your rubber band. What do we need to do to the rubber band to make it into this green one? What would you say? What is it? Stretch it, yes. Get it? If I get it from the edges, won't you stretch it to make that green one like that? Okay. All right. Keep that in mind. Let's go to the next transformation. Look up. What does this one say? Take f of x and multiply times what? 1/3. So what is 9 times 1/3? That's 9 over 3, which is 3. Yes. Next. What is 4 times 1/3? That's 4 and 1/3. 4/3. And this simplifies to 1 and 1/3. Next, what is 1 times 1/3? 1/3. Then 0 times 1/3 is 0, and the rest repeat, yes? 1/3, 1 and 1/3, and 3. Let's graph that. -3, 3. -2, 1 and 1/3. -1 and 1/3. 0, 0, 1 and 1/3. 2, 1 and 1/3. And 3, 3. Okay. So, we said we started with the original one, and then you said that when we multiplied times 3, it stretched, but now we multiply times 1/3, what happened to the original one? Tell your neighbor, what happened to the original one to get that red one? Alright, let's see. Noor, what happened to the red one from the original? Okay, so the green one stretched. The red one, yeah, I see you guys making motion like this. What would he call that? Compress. That is correct. Stretch. Compress. Okay. So, let's generalize this idea. Look up, please. Look at this one. What did we multiply to stretch it? And this one, what did we multiply to compress it? What would you say in general terms? Talk it over to your neighbor. What would you say in general terms? And let me get you started. If I multiply f of x by what, and so on and so forth. What would you get? Talk it over to your neighbor. I'll be nice. My goodness. All right, let's see. Andy, if we multiply f of x by what happens? By what? Okay, help him out, please. Philip. 2. Okay, so if we multiply f of x by 2, what would happen? If we multiply times 5, what would happen? So how can we generalize that idea? Tell your neighbor, please. How can we generalize that idea that Philip just said? All right. Let's see. Pamela, if we multiply f of x by a whole number, write that down, please. A whole number, we stretch. Okay. Comma. And if I multiply f of x by what happens? Who can give us the last part? Thank you. Fraction by a fraction slash decimal. What happens, Juliana? It compresses. Thank you. Yeah, it's a general idea, yeah. Now, one thing to notice, though, once again, well, the major thing to notice is that the number now, it's in front of f of x, to the left of it, yes? Because if this number was to the right of it, it would be what? K, wouldn't it? Yes. But now it's to the left, so now it's a new parameter. So that new parameter is known as A. So our general rule now changes. Copy this general rule, please. G of x equals A times f of x minus h plus k. G of x equals A times f parentheses x minus h close parentheses plus k. And reminders for us, what do I write next to k to remind me what it does? Yeah, arrows up and down to remind me that if it's plus, it goes up, minus, it goes down. How about h? Left and right. So right if it's positive, left if it's a negative number that we substitute in there. And our new one, I'm going to change to blue, which is the parameter A. That one does two things. We said it did what? It stretched or compressed. Stretch if it's a what? Whole number. Compress if it's a fraction slash decimal. All right. So like I said earlier, the one I showed you, it only had A. It didn't even have H and K. Did you guys notice that? It was just a simple one. So how about we do one with all of them together, yeah? Everybody happy together, yes? All right. Turn your paper over. Here we go. Copy this one on the top left. Example, Star Wars Q. It says, graph f of x equals x squared using the domain -2, -1, 0, 1, and 2. Then graph the transformation g of x equals 3 times, open parentheses, x minus 4, close parentheses, squared, plus 2. Copy that really quick, and we'll do that one together. And just for getting you started, on the left side of your graph, also start a table so we can graph the parent function for the quadratic. -2, -1, 0, 1, and 2. Fill this in and graph your parent function, and we'll go from there. Copy that, please. All right, here we go. So -2 squared is 4, -1 squared is 1, 0, 1, 4. Get used to these because we're going to be using these a lot, okay? So let's graph that. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. This is going to be our bread and butter, so make sure, once again, you get used to these. We're going to label this f of x. All right? Our final transformation I'm going to do in red. Okay? So before I do the final transformation, now if we put our transformation goggles on, look at this transform function, look at it. You can actually see what it's going to do now. Yes? Tell your neighbor if it's going up and down or left and right. Tell your neighbor where we're going with those two, please. Wow, man, how mean some of you. Let's see. Help us out, please, Audrina. Are we going up or down? Up. So put a little arrow showing that it's going up, because we're going to get to that towards the end. How about left or right, Brooke? Are we going left or right? right. So put an arrow pointing right. So how many steps right? 4. How many steps up? 2. Okay, we got that and we can picture that movement, yes? But what is the one thing that we cannot picture yet completely? This. But now with the general rule that we came up with, if it's a whole number, what's going to happen to this? It's going to stretch. But we need exact points to where it's going to stretch. So to do that, we're going to do one more table just for the part A. So I'm going to do this. My goodness, computer. That's what I thought. All right, x. And instead of f of x, we're going to do what? 3f of x. Yes, because of this parameter a. So we got -2. What is f of x at -2? That's 4 times 3, that's 12. Next one, -1. What is f of x? 1. 1 times 3 is 3. 0, 0. And then the rest repeat. 1, 3, 2, 12. All right? So, let's plot this to see what it looks like. -2, 12. -1, 3. 0, 0. 1, 3. 2, 12. All right. Now, did it stretch like we thought? Yes. But is that the last function? No, we still need to do what? 4 to the right and 2 down. So I'm going to use now red for my final transformation. I'm going to start with these 2 points at the top. I'm going to go 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. Oh, it's going up? Okay, my bad. Yeah. I did that to see if you guys were paying attention. So, 1, 2. Let's go. Technology, I love it. Let's see if I'm right. 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. Yes. Okay, let's go to these two. 1, 2, 3, 4. 1, 2, 3, 4, 1, 2. Okay, this one. 1, 2, 3, 4, 1, 2. And last but not least, 1, 2, 3, 4, 1, 2. And this one we're going to label g of x because it's our final one. From 1 to 5, how comfortable do you feel with these? Yeah, 5 4s, 5 4s, 5 4s. So what's the only thing new that we introduced today? A. Okay? So you have an extra graph paper, yes? All right. So next to that, I want you to do this next one by yourself really quick. Actually, we're almost out of time, but still, write it down, please. Let's do. Oh my goodness, not that one. Hold on. I'm going to change a couple of things here. Uh-oh, here we go. So, example, Michael Jordan Q. I'm going to give you 1/3, and then plus 5, and minus 3. All right. Before we do anything, tell your neighbor what's going to happen to the original function according to vertical, horizontal, and if it compresses or stretches. Talk it over to your neighbor. All right, good conversation. Lenny, so up or down? Down, so put an arrow pointing down. Left or right? Left, 5. Stretch or compress? Compress, that is correct, because it's 1/3 compress. So you know what to do. Table for your original, you plot it, and then a table for 1/3 f of x, you plot that, and then at the end you move it those steps. So, home plate for tonight. Let's see. Once again, it's only 3 transformations. By now, with your transformation goggles, you can see what the green one does, the blue one does, and the red one. Have a good one, guys. Tutoring after school. Be there or be elsewhere. Have a good one. Bye. Jerry Home Plate.